Good morning, students. So today we're going to talk about reaction of base with metals. In the last lecture, we have talked about reaction of acid with metals. So we know that on reaction of acid with metals, we get hydrogen gas. And also we have talked about that not all metals give hydrogen. Only the reactive metals give hydrogen, that too with dilute HCl and dilute H2SO4. Now let's talk about reaction of base with metals. First and foremost thing I want to talk about, base are of two kinds. Water soluble base, which are known as alkali, and water insoluble base, which are just called base only. Alkali, for example, sodium hydroxide, potassium hydroxide, and base are here copper hydroxide, ferrous hydroxide, ferric hydroxide. So you can see base are of two kinds, water soluble base and water insoluble base. I repeat, water soluble base are known as alkali and water insoluble base are known as base. So we can see that all alkali are base. All alkali are base, but not all base are alkali. As we can see, these two are categorized under base. So all alkali are base, but all base are not alkali. Is that clear? And what do you understand by soluble? They get dissolved. Like for example, salt, if you add in water, it get dissolved and it disappear. That's called solubility. That's called soluble. So this NaOH, QH are soluble bases. That's why they are called alkali. They are strong base. And this copper hydroxide, ferrous hydroxide or ferric hydroxide, they are just base. They don't dissolve. The precipitates are insoluble. Now let's talk about reaction of base. So here we have taken zinc as a metal over here in a solid state on reaction with NaOH. NaOH is generally or usually we can say it is in solid state. It is a solid compound. It is not liquid. If you want to make liquid, we can add water and make NaOH solution. That's called aqueous solution. So you can write in this way, ZnNaOH plus water, or you can write in this way, Zn plus NaOH in aqueous solution. Both are okay, both are right. So on reaction with NaOH, NaOH is a alkali, is a base, we get sodium zincate plus hydrogen gas. So the main product here is, we can say, sodium zincate and hydrogen gas. So we can see in base also we get hydrogen gas. Sodium zincate, the valency of zincate is -2 and that of sodium is +1. So you can see the 2 goes over here, and that's why the formula is Na2ZnO2. But now the question is, do all metal react with base and give hydrogen gas? No, it's not so. As in the last lecture, we have discussed about the reactivity series of metals. That potassium is highly reactive metal, and going down the series, gold and platinum are the least reactive. So some metals are non-reactive, some are highly reactive, and some are moderate. Okay, now let's talk about why we have taken as zinc. Because not all metals gives hydrogen gas with base, or we can say these are alkali. All metals do not react with alkali. Only zinc, aluminum, lead. You can see these three metals, zinc, lead and aluminum. These are reacting with base, and this also react with acid. So those compounds which react with acid and as well as with base are known as amphoteric compound. I repeat, those compounds or those elements which react with base and as well as with an acid are known as amphoteric compound or amphoteric substance. In other words, we can say they are reacting as an acid, they also behave as a base. So sometimes they behave as acid, sometimes they behave as a base. So that's why such elements are known as amphoteric element or amphoteric substance. So you can see zinc in solid state react with potassium hydroxide, we get potassium zincate plus hydrogen gas. Aluminum plus NaOH in aqueous solution, we get sodium aluminate plus hydrogen gas. Lead plus sodium hydroxide, we get sodium plumbate plus hydrogen gas. Now you can see I have written K2ZnO2, NaAlO2, Na2PbO2. In zincate and plumbate, the valency of zincate and plumbate is -2. You can see plumbate and zincate, they are having -2 valency. But in case of aluminate, the valency is -1. So that's why I have not written 2 over here. Potassium zincate K2ZnO2. Sodium aluminate, there is NaAlO2. There is no 2 over here. And plumbate also Na2PbO2. So in zincate and plumbate, valency is -2. But in case of aluminate, it is -1. And in all three cases, we are getting hydrogen gas. So we have seen that in acid also, in base also, we get hydrogen gas with metals. But remember that not all metals give hydrogen gas. Now we are going to talk about the reaction of acid with metal hydroxide and metal carbonates. Let's see. Okay, dear students, our next topic is reaction of acid with metal carbonates and metal hydrogen carbonates. Metal hydrogen carbonates are also known as metal bicarbonates. MCO3, MHCO3. Here M is just I have taken as a metal. There is no such, we can say, element M. I just denoted M as a common metal, MCO3 and MHCO3. Now let's see the reaction of sodium carbonate. Na2CO3 plus HCl, that is hydrochloric acid. We get salt, that is NaCl plus carbon dioxide plus water. So dear students, whenever a carbonate is reacting with acid, whether it is dilute HCl or concentrate HCl, you will always get carbon dioxide gas and water when you are treating a carbonate with an acid. For example, if we have a carbonate salt and if we add acid, you will see a brisk effervescence of carbon dioxide gas. What is brisk effervescence? A quick bubbling out. If you see Eno or if you see the soda water, there is a bubble coming out. So that is a brisk effervescence of CO2 gas. So sodium carbonate when react with HCl, or if you take even sulfuric acid or nitric acid, you can take any acid. Any acid when react with carbonate. What is carbonate? If you see CO3, it means it is a carbonate salt. And carbonate easily turns to carbon dioxide gas. Carbon dioxide gas is a more stable than carbonate. Here carbonate and carbon dioxide both are oxide of carbon, and this oxide of carbon, that is carbon dioxide, is more stable, so it easily transforms into carbon dioxide gas. What you have to remember, whenever a metal carbonate reacts with an acid, we get salt and carbon dioxide gas and water. Now you can see, now we have to balance this equation also. Let's see, for example, here we had Na2CO3. We have Na2CO3. Na2CO3. Here just we have Na. So I will just skip 2 over here. We have H2O. I will put 2H. And everything is balanced. 2Cl, 2Cl, 1 carbon, and 3 oxygen. Now let's talk about NaHCO3. That is sodium hydrogen carbonate. Sodium hydrogen carbonate is also called sodium bicarbonate, which is actually a baking powder which we use in our kitchen. Sodium bicarbonate plus HCl, hydrochloric acid. The same reaction, we get same thing, NaCl plus CO2 plus H2O. So what we have to remember here, whether it is a metal carbonate or whether it is a bicarbonate or hydrogen carbonate, we get carbon dioxide and water and the salt, respective salt. If you take HCl, you get NaCl. If you take H2S4, you get Na2SO4. Now let's see certain examples over here of metal carbonates. K2CO3 plus H2S4. As I said, you can take any acid. Potassium carbonate plus sulfuric acid, you get potassium sulfate plus carbon dioxide plus water. The arrow indicates the gas is, we can say, evolution of gas, or gas is escaping out. Potassium carbonate plus HCl gas, potassium chloride, carbon dioxide and water. Magnesium carbonate plus HCl gas, magnesium chloride plus carbon dioxide, water. Calcium carbonate like chalk plus HCl, you get calcium chloride, carbon dioxide and water. So this was about metal carbonates and metal hydrogen carbonates. We can here gain some knowledge like NaSO3 is also known as baking powder, and washing soda is actually Na2CO3.10H2O. Sodium carbonate decahydrate, that is, it is having water of crystallization, so that is called washing soda. Now you can even take same example with sulfides. If you take sulfide, we can learn something new, which is actually same. Na2CO3, Na2SO3, you get SO2 gas. So if it is sodium sulfite, if you take sodium sulfite, the reaction is occurring the same way. Here it was CO3, here it was CO2. If you take sulfite, sodium sulfite, that is metal sulfide, you get sulfur dioxide gas and water. And if you take metal hydrogen sulfide, you will get the same thing. Here you will get SO2 gas. Fine. So this was about